Hello and welcome to the final video of the root finding method series. In this video, we will learn about the secant and modified secant methods. Previously, we saw that the Newton-Raphson formula requires the derivative of a function, evaluating which can be a challenge for some functions. The secant method solves this problem by approximating the derivative in the Newton-Raphson formula by a backward finite difference, which leads to this iterative equation. As you can see, we now need to guess at I minus 1 and at I to compute the estimate at I plus 1. However, this is not a bracketing method since there is no sign change requirement for the function between these two guess values. We can further modify this to use an initial guess and a perturbation parameter. This leads to the modified secant formula. Now let's see how we implement these two methods in Python. Let's look at the function calls for the secant and modified secant methods. The secant method requires the two initial guesses, whereas the modified secant requires a single guess and a perturbation parameter. This is how the main while block looks in secant and modified secant method. If you have seen the previous videos, you might have noticed that code structure remains almost the same for all methods. One change that we did in all of these methods is the way we estimated the root value for the next iteration. If you are not familiar how this code works, please check the previous videos for a more detailed explanation. Let's now run these methods on the same quadratic function that we used in the previous videos. As we can see, both methods successfully identified the two roots of the quadratic function. With this, we conclude our video and the series on root finding methods. I hope you liked it. Thanks for watching and see you in the next video.